Hello, this is Tyler Young from Team 2 of Engineering 102-701, Summer 2026. And this is our final project of the semester, Composite Bingo Code. Simulation is a major tool in engineering because it lets us test systems without building physical prototypes. For this project, we used Bingo as a simple but effective way to explore simulation concepts like randomness, pattern recognition, and structured rule. Our goal was to build a full MATLAB simulation of a two-player bingo game using only composite numbers. Let us practice algorithm design, matrix operation, and conditional logic while showing how randomness interacts with a controlled computational system.
For this project, we created a composite bingo game using MATLAB. We started by breaking the program into different functions to keep the code organized and easier to work with. The program created bingo cards using composite numbers while making sure there was no repeated numbers on each card. We also made sure that each card followed the project requirements and was generated correctly every time the program ran. Next, we added a system that randomly called numbers and automatically marked them on bingo cards when there was a match. We then wrote code to check for winning patterns, including rows, columns, and diagonals, so the program could tell when a player had won. Finally, we tested the program several times using different bingo cards and number sequences to make sure everything worked correctly. These tests helped confirm that the cards were generated properly, numbers were marked accurately, and winners were identified every single time.
For our results, the program successfully generated 2 bingo cards using only composite numbers with ranges for each column. During the game, numbers were called randomly each turn, and the cards updated automatically when matches were found. As the game progressed, more spaces were marked until a player achieved the winning pattern, like a row, column, or diagonal. We tested the program multiple times and got different results each time, including wins for different players and even ties. Overall, the results show that programs worked correctly with no major errors, and randomness made each game unique.
In the discussion section, it was stated that the composite bingo program had been successfully in meeting all its objectives. The program could create valid bingo card using composite numbers, update the card as the number were called, and identify the winning patterns correctly. Another important observation was the differences in the numbers of turns to win for different games, since the bingo cards and called number are randomly generated. This to be expected when we run the simulation, as each time we run the simulation, the outcome will be different. The program also removes duplicate calls of numbers and correctly accounted for marked spaces throughout the entire gameplay. In some simulations, one player won first. In other simulations, both players got bingo at the same time, so there was a tie. This confirmed the win-checking algorithm works for rows, columns, and diagonals. In summary, the results showed that the simulation was valid and met all the requirements of the project and a successful representation of a composite number bingo game.
In conclusion, the composite number bingo program successfully generated 2 unique bingo cards, simulated random number calling, and detected wins through rows, columns, and diagonals. The system avoided repeated values, updated each turn, and demonstrated effective use of loops, conditionals, and matrix operations to model a complete and accurate bingo game.